Hi everybody. Hi. How are you? How are you? How are you? I hope everybody is okay. I hope everybody is okay. Hi Ritika. Hi Pushpa Sharma. Hi Udayashri. Hi Samruddhi. No, so nice for you guys to be here. So nice for you guys to be here. So have you guys studied already SHM? How many of you are already in class 12th or are going to give the NEET paper very soon, NEET or J paper. Hi RP, hi RP. How many of you have already studied this chapter? If you have, just give me a thumbs up in the chat. If you have already studied this chapter, hi Hiya Gupta, hi KSRP. If you have already studied this chapter, SHM. I don't know if you guys have seen this chapter before. Studied this chapter. Ayush. I don't think you have studied this chapter. Have you, Ayush? Okay, if you have, give me a thumbs up in the chat, guys. Give me a thumbs up in the chat. If you have, Venkatesh has, Ayush has. Oh, Pranjal, do something for class 11. Pranjal, I am doing for class 11 tomorrow. Okay, I am, no, not tomorrow, day after tomorrow. I am doing for class 11. Today I did something for class 11, right? I talked about conduction. Okay, so you can check out that lecture. Okay, all right, to 2021 wale ho. Oh Ayush, oh, okay, very good. Hi Tirupati Reddy ji. Okay, all right guys, so you are here for short tricks on SHM. Okay. Mm, SHM is a very important and also it's a very complicated topic with very diverse kinds of questions. Okay, very different types of questions from all subjects can come in SHM. So in order to study this, we will need to वो ओके टाइम पीरियड वाले ही बता रहा हूँ आयुष वाले टाइम पीरियड वाले ही बता रहा हूँ ओके सो गाइस what we are going to do is very simple. Okay, I have a very hard question that I will try to solve within 2 minutes. Okay, I have a very hard question which I will try to solve in 2 minutes. Okay, Pradeep Singh kinematics अभी चालू हो जाएगा दो थोड़े दिनों में. Don't worry. As soon as I finish it, I will start with that only. Okay, so first of all, we have a very hard question. I will do a very hard question within 2 minutes. Okay, so which using my short trick. Okay, so what question we will try to solve in 2 minutes? This is the question which we will try to solve in 2 minutes. Okay, the question here is I don't know if you guys can see the question because I have not written the question, but the question is find time period of this block. Find time period of this block. Okay, find time period of this block. All right. Okay. So it's a complicated question, and with my short trick, we will try to solve this. With my short trick, guys, we will try to solve this within 2 minutes. Okay, that's the goal here. That's the aim here. Okay. So when we start solving this question, you can see whether it happens in 2 minutes or not. Okay, but before we get to that question, let's discuss a little bit of basics. Okay, so we are going to solve this question, but first of all, in this case, if I ask you the time period, do you guys know what the time period is in this case? Do you guys know the time period, what it is in this case? Everybody should know. Everybody should know. What is the time period? What will be the time period in this case? What will be the time period? It's very simple. This is a basic question. The time period is 2 pi under root m by k. I hope everybody knew this. I hope everybody knew this. It will be 2 pi under root m by k. Okay, very simple question. You were supposed to know this, guys. You were supposed to know this. Okay, anyways, next question, one more basic question. If I have this spring block system, in this case, if I ask you time period, how much will be the time period in this case? How much will be the time period in this case? In this case also, guys, if you see, there is an extra force here which is mg sine theta. Okay, and there is a force here, the spring force, which is kx. Now if you see, one of this force is a variable. Okay, and the second force is a constant. Okay, now you have to understand this, guys, and this is very important. Everybody should know this. You have to understand this, and that is that constant forces do not change the time period. Do not change the time period. Okay, the constant force, if I have an extra constant force is only going to change the mean position. The variable forces decide the time period. The variable forces decide the time period. Okay, so in this case also, if I ask you the time period, it should be the same. What will be the time period in this case? It will still be 2 pi under root m by k. You have to understand this. Mg sine theta is a constant force, will not change the time period, so it will be same as the previous case. It will be same as the previous case. Okay. Now similarly, if I ask you what will be the time period in this case, so it will be nothing but once again t is equal to 2 pi under root m by k, because once again I have just one extra force, which is the gravitational force in downwards direction. It is not going to change the time period. Okay, if I ask you the time period in the next case, here what will be the time period? So here also the time period will once again be same. It will be equal to 2 pi under root m by k. The situation is not very different. What if I keep this block and the spring? What if I keep this block and the spring inside a lift? Let's say I have a lift. Okay, and inside the lift, I have kept the spring and the block. And if I ask you here, what is the time period? Here also, you have to remember now there are two extra constant forces. The mg force will be downwards, but also the ma force will be downwards. Okay, you can't see this, can you? Can you see this? Can you see this? Can you? I don't think so. I don't think so. There will be two forces in the downwards direction. Guys, if you make the bow diagram of the block, okay, there will be mg in the downwards direction, ma in the downwards direction, and kx in the upwards direction. Both these forces are constant, so they will not change the time period. So once again, time period will just be 2 pi under root m by k. Okay, the time period is only decided by the spring force, which is 2 pi under root m by k. I hope everybody can see this. Okay, because I can't see this here, but if you can see it, very good. Okay, next, once again, if I had a spring lift going downwards, once again, yaar, अरे मतलब अब तो मैं थक गया बोल के, time period will be equal to 2 pi under root m by k. Time period will be 2 pi under root m by k. Okay, even in this case. Now, next case, if I had block dipped inside a liquid like this. Now here it will have two forces. Okay, it will have two forces. First it will have a weight in downwards direction. Okay, and next it will have a buoyancy force in upwards direction. Okay, weight in downwards direction and buoyancy force in upwards direction. This will be a constant. This will be a constant. For small oscillations, even buoyancy force will be a constant. So here once again, guys, here once again, Ryan Faris, yes, I will try to do that. Okay, yeah, once again, guys, here what will be the time period? Once again, it will be 2 pi under root m by k only, because these both are constant and constant forces. So they will not change the time period. Only kx is a variable force here. So time period will just be equal to 2 pi under root m by k. I hope everybody understood. I hope everybody understood. Next, what if I ask you time period of this system? What if I ask you time period of this system? So now in this case, once for the first time here, the time period will not be here. For the first time, time period will not be 2 pi under root n by k. Okay, why am I saying that? Why am I saying that? Here first, once again, weight will be downwards. Okay, and force of buoyancy will be upwards. But if the block oscillates up and down, if the block oscillates up and down, then this will be a variable. When the block oscillates up and down, this will be a variable. And of course, the force, the spring force is kx. That is also variable. So the time period will be different here. I hope everybody can understand. I hope everybody understood. Okay. सबको समझ आना चाहिए, सबको समझ आना चाहिए. Okay, so apart from this case where the block is half inside the water, time period so far we have seen for every case is 2 pi under root m by k. But now let's try to complicate things. What will be the time period for this case? What will be the time period for this case? I want everybody to take a minute and guess. What will be the time period for this case? Everybody take a minute and guess. Okay, everybody should know. What will be the time period for this case? Anybody? Any idea? Any idea? Any idea? Any idea? See how to do this, guys. How to do this? Here, if you see, this length is a constant. This length is a constant. And if you see, this length is also going to be, the string from here to here is also going to be a constant. Okay, so if you see, the entire system from here to here is just can be treated as a fixed system. The entire system inside this boundary is a fixed system. Nothing inside it will move. Can you see that? Nothing inside this system will move. Everything will remain as it is, even if the spring, the block is going up and down. Okay, so what that means is that I can just replace this system by this system and everything will still be same, because things inside here are just fixed. The things inside in this region are just fixed. Can you see that? Can you see that? I hope everybody can see that. Okay, everybody should be able to see that. Nothing is changing. So this system can just be written as this system, and I can just say here also time period t will be 2 pi under root m by k. So far, once again, everybody knows, everybody understood. Yes, 2 pi under root m by k. If you understood, guys, by the way, give me a thumbs up so that I know you understood. If you understood, go give me a thumbs up so that I know you understood. Okay, all right. Now let's start talking about, now that everybody knows the basic, let's start talking about the shortcut. Okay, so what is the shortcut? The first shortcut, if I have a system like this, okay, then I can shift the spring from one side to the other side. If I have a system like this, okay, I can shift the spring from one side to the other side without any change. I can, if the K was here, I can just shift it to the other side. I can shift it to the other side and it will still be K. Okay, if the spring constant was K on one side, it will still be the spring constant K on the other side. Okay, this is the first rule. This is the rule for a shortcut. Okay, so if you try to prove this, it will take a lot of time. Do not try to prove this. Just assume that मैं बोल रहा हूँ, I'm telling you it's correct only. Okay, if I say something, I have done research and everything, and this is correct. Okay, so you are allowed to do this. If you want to shift a spring from one side to the other side, you are allowed to do this. Now, how is this useful for us? So let's say a question is like this. I have two springs here and I have to calculate time period. How do I do this? Now see, this question looks very difficult until you realize that you can shift the spring. If you shift the spring, guys, if you shift the spring from here to here, if you shift the spring from here to here, from here to here, okay, now things achanak say immediately things become very easy, because you see that in this case these two springs are just in series, and I can immediately write the k equivalent as k1 into k2 divided by k1 plus k2. Okay, I hope everybody knows how to calculate the equivalent spring constant in series. That will just be equal to k by 2. So in this case, now if I ask you once again, if you look at the remaining system above, this remaining system above can be just considered as a fixed system. So what I can just say is that this is nothing but a spring and a block with the spring has a spring constant of k by 2. If I ask you what will be the time period, the time period will be on to 2 pi under root time upon k by 2. Everybody knows how to do the 2 will go upstairs. Okay, that's not important here. Okay, everybody should know how to solve this. Okay, it's a very important shortcut, guys, and this has so much usages. Okay, so now that was just one example. Okay, there are two more rules. If I have spring like this, okay, let's say I have a pulley and a spring like this, and I have a pulley and a spring like this, and let's say I want to shift a spring from here or from here to here. Okay, from here to here or from here to here. So now remember, guys, okay, remember this is the magic trick here, but you have to remember small little things. Okay, this is a magic trick, you have to remember the small trick. If you are shifting like this, you have to either multiply by 4 or divide by 4. If you are shifting like this, you have to either multiply by 4 or divide by 4, depending upon what the situation is. And you will need to remember this here, guys. You will need to remember this here. Okay, if you have the first situation, then you have to divide by 4. If you have the first situation, you have to divide by 4. If you have the second situation, you have to multiply by 4. Okay, the first situation divide by 4, the second situation multiplied by 4. Will you guys remember this? If you can remember, it's a small thing, but you will remember this. And if you can, just give me a thumbs up. If you can remember this, give me a thumbs up. Everybody, if you can, right? Just give me a thumbs up if you can. Everybody, if you can, just come on, remember this. You can. Now, short trick sometimes you have to remember. Now, so it's very simple, but you have to remember. Okay, so now guys, let's use this to solve a question. I have a question, find time period here. I have a question, find time period here. So what will I do, guys? What will I do? It's so simple here now. What will I do? What will I do? Tell me what will I do? I will just shift the spring. Shift the spring, shift the spring, shift the spring, shift the spring. Now, as soon as you shift the spring, guys, you can see that the remaining part of the system is fixed. Nothing there will move. So you can just treat it as a spring here and a block here with the spring constant k by 4 and time period 2 pi under root m upon k by 4. So simple. Okay, can we do one more question? Can we do one more question? Can we do one more question? Okay, this one even looks even more complicated, but once you start using this, it's even more simple. Okay, so I have now two springs K and 3K. You have two springs K and 3K. Okay, and you have to find the time period. How to find the time period, guys? How to find the time period? Very simple. You shift both the springs one by one. First, we shift the first spring. Okay, I shift the first spring, K it becomes 4K. And then I shift the second spring, 4K becomes 12K. 4K becomes 12K. Okay, now here guys, if I see the above system is nothing but a fixed system. The above system, nothing will move here. This string is fixed. This pulley will also be fixed. Nothing will move here. Okay. So what I can do is I can just treat it like this. Okay. When I can treat it like this, I can just very easily calculate the K equivalent. The K equivalent is 4K into 12K divided by 4K plus 12K. Okay, that will be equal to 16. 12 by 4 is 3K. Okay, which gives me T is equal to 2 pi under root m by 3k. Simple, simple, simple. Yeah, 3m by k or m by 3k. It will be m by 3k, Paladi. Yes, it will be m by 3k. Okay, very simple shortcut, guys. Very simple shortcut. You can use it to solve the next question. Now, guys, this one I will tell you to solve. Okay, everybody can solve it. I know everybody can solve it. Very simply solve it and tell me the time period in the chat. In the chat, in the chat. Tell me the time period in the chat. Yes. Thank you, Ashutosh. Thank you, thank you, thank you. Jolly, jolly, jolly. Calculate and tell me the time period in the chat, in the chat, in the chat. Everybody, everybody, everybody. In the chat, in the chat, in the chat. Chalo, 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 chalo. Come on, come on, come on, come on. Chalo, 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 chalo. Come on, come on. I know you can do it. I know you can do it. I know every one of you can do it. 4 pi under root m by 5k हो गया अरे रे there is one answer there already. It will be 4 pi under root m by 5k or just 2 pi under root m by 5k. Okay, guys, how do we solve this? How do we solve this? See, first I will shift the first spring, so it will go from k to k by 4. From k to k by 4. Okay, next I will shift the second spring, so it will go from k to k only because I'm shifting on the same string. Okay, so it will go from k to k only. Now I have two springs in series like this. Now I just have two springs in series like this, and I can easily calculate the k equivalent as k into k by 4 upon k plus k by 4, which will be equal to k by 5. Okay, if I'm not wrong, it will be k by 5. Yes, so it will be, the time period will be 2 pi under root m by k by 5. Very, very simple. Very, very simple. You can use this, to all the different things. Okay, you can use this to all the different systems. Let's go back to the question where we started this video. Let's look at this question. It looks so complicated, right? There are 6 different springs here. Oh my god, so many springs. So many springs. But guys, it's not very hard now. You just keep shifting the spring. First, I will shift the first spring. So it will become k by 4. Then I will shift the second spring. Another k by 4. Then I will shift the third spring. Another k by 4. Then I will shift the fourth spring. Another k by 4. Then I will shift the fifth spring. Oh, another K by 4. You see, immediately it became so simple. So simple. Now you have to shift the remaining springs. Now you have to shift the remaining springs. What am I talking about? What am I talking about? What am I talking about? See, after this, you shift the spring below the above the mass. Okay, so I will shift the first spring. Oh, it will be K by 4 and K by 4. Then, if you see the second spring here, this spring will take some time, but this can also be shifted. Okay, this spring can be shifted in two steps. This spring can be shifted in two steps. Okay, two steps. How do two steps? First, I will shift it here. Okay, from here to here, and then I will shift it to here. Very simple, very simple, very simple. I hope you guys can see. I hope you guys can see. Okay, similarly, I can shift all the springs. Okay, the next spring if I have, I will shift it from here to here. K by 4 remains K by 4. Then I will shift it from here to here. K by 4 remains K by 4. Then I will shift it from here to here. K by 4 will still remain K by 4. Okay, K by 4 will remain K by 4, K by 4, K by 4. Overall, what will happen after a lot of shifts? What will happen is all the springs can be shifted and you will have just a simple diagram like this. You will just have a simple diagram like this. Okay, and if you see, you can very easily calculate the time period here. Udayan show, please rewatch this video from the beginning. You will understand, my friend. Okay, if you see this entire system, this entire system is just fixed. Okay, this entire system is just fixed. Okay, so I can write what 1 by k equivalent is 4 by k plus 4 by k plus 4 by k plus 4 by k. Okay, 1, 2, 3, 4, 5 plus 4 by k plus 1 by k. Okay, that will be equal to 21 by k. So k is equal to k equivalent is k by 21. So time period t is 2 pi under root m by k by 21. Easy peasy, guys. If you love this, I know if you love this. Okay, this is what I want you to do. Okay, don't just keep it to yourself. Share it with your friends. Okay, share with everybody. Tell them this is a very good short trick. Okay, a very good short trick, and it works. It works as long as you have massless police. It works as long as you have massless police. Okay, massless and frictionless police, if you have, it works. Okay, so tell it to every one of your friends, like this video, share this video, and subscribe to our channel. Okay, because I have a few more tricks up my sleeve. I will share them. None of the tricks will be shared tomorrow, but I will share other tricks as well. Okay, and subscribe to our channel, share it with your friends, and for 2 minutes, let's talk about Vedantu's Pro subscription. Okay, for 2 minutes, let's talk about Vedantu subscription. So, if you want to prepare for JEE or NEET 2021 or 2022, Vedantu's platform is just for you guys. It's the best platform out there. If you take the Pro subscription, guys, you get what? You get full access to all the live courses where all the subjects will be covered in great detail. Everything, you can choose your language. You want to choose Hindi or English as a medium of studying, you can do that. Okay, you can have instant in class doubt solving. You have class teachers in class who will solve each and every one of your doubts. You can ask as many doubts as you want. Okay, and all our teachers are the India's best teachers. All of them have more than 5 years of experience, all of them with the prime colleges of India. Okay, and you can learn from the safety of your home. Okay, so how to get the Vedantu Pro subscription? First of all, let's talk about how much it costs. Okay, so if you are going to take 1 month subscription, guys, it's going to cost 6,999. If you're going to take 12 month subscription, it's going to cost 31,800. Okay, these are the prices for 3 months and 6 months subscription. But if you use my coupon code, AAPPRO, if you use my coupon code, guys, what happens is you get additional 15% discount. Okay, so if you use my coupon code, the prices will change from this to this, from this to this, from this to this, and from this to this. Okay, which becomes the per day price. If you guys see, it's very less. This is like nothing but a McDonald's ka burger. Okay, so guys, if you want this, if you want to study at Vedantu, go to vdnt.in/ytpro. Go to vdnt.in/ytpro. Okay, and use my coupon code. Okay, even if you don't want to take pro subscription, at least go and check out the website, guys. We have so many fun things for you. Okay, we have an interview with Deepika Padukone, we have an interview with क्या नाम है उनका Vidya Balan, we have interview with PV Sindhu, we have interviews with the all India toppers, all of them just for you. Okay, and all those videos you can check out for free. Okay, so just go to Vedantu's website and check out the free lectures that are there for you. Okay, and if you want to take the pro subscription, use my coupon code to get the additional 15% discount. Okay, so that's it for today's video, guys. That's it for today's videos. If you liked it, please like it and share it and subscribe to our channel and share it with your friends. Okay, let them see this short trick. This is a very important short trick. Okay, so share it with your friends, share it with your friends. Okay, and that is it for today, guys. If you have any comments, if you have any questions, you can write it in the comment section. If you want the PDF of this, I will share the PDF of this in the comment section in some time. Okay, so in the meanwhile, guys, I will stop this class here and we will see you later. Okay, entertainment 2015, by the way, is asking, sir, is it in series or in parallel? Entertainment 2015, if you see, all these are in series, and for springs in series, this is the formula you have to use. Okay, this is for springs in series, this is the formula you have to use. Okay, all right, guys, I will see you later. Have a nice day. Bye bye. Share it with your friends. Bye.